Hello. So today I'm going to show you how to use the mags from GMGC. So GMGC is the Global Microbial Gene Catalog, and mostly we discuss it as a gene catalog, but actually we've also made available a lot of mags, metagenome-assembled genomes, for all of the habitats in the data set. And so I think today I'm just going to show you how you can get the metadata for some of them. So you can select, because there's a lot of them. So we'll show you how to select which ones you want and how to get the FASTA files for it. So let's start, and as usual, I'm going to use Mamba. I'm going to create a GMGC mags tutorial, and I'm going to use Python 3.9. And as I always say, so use Mamba because it's much faster than Conda, than straight Conda, but otherwise it uses the same packages, it's built on the same system. Mamba is kind of Conda 2.0. So here, as before, activate next tutorial. Okay. And Mamba install, and I'm going to use Conda Forge, and I'm going to install here. Let me move this a little bit so you can see what I'm typing. I'm going to install pandas. I'm going to install requests, and I am going to install this package called git-nx, which we'll see in a second. Okay, so I've prepared everything beforehand, so everything's in cache, so everything just downloads very quickly. I guess maybe there's been some updates since yesterday when I was preparing this, but on your side it might take a tiny bit longer. Okay, so you can get the data from GMGC going through the website. But here I'm going to show you the more advanced version where we get the data, the tables, and then we process them ourselves. And so the first thing we do is I'm going to copy and paste this. I'm going to clone this repository here. Okay, and so here if I look, so this repository is a Git repository, but it's also actually a git-nx repository, which is and git-nx builds on top of Git. And what it does is it adds this support for very large files. And a bit like Git itself, git-nx is actually really powerful and it does a lot of things, but we can get away with doing our work, maybe knowing 1 or 2% of the whole power. So this is what we're going to do here. So first of all we're going to use git-nx to actually get these a couple of files, and here the one I'm looking for is this GMBC10 meta-tsv, and so now it's going to download those. So this might take a little bit longer. So the internet here at where I am is quite fast, so that was quite good. And so this got the metadata for GMBC. So these are the Global Microbial Bins catalog. So we call them all bins, and the ones that are high quality enough, we can call them mag as well. But as you can see in the paper there, we've actually, for scientific reasons, it was actually good to have a set that was unfiltered, because we can then also always filter it a little bit more. Okay, so we got that. Let's get also the metadata for the samples, and this is GMGC sample metadata. So this is GMGC 1.0 sample metadata. Oh, and what is this? Oh, okay. Okay, so this was just so I have a git-nx. I have now 2 versions of git-nx. I have one that's installed on my machine, and then apparently this was shadowing the version that I just installed with Conda. Okay, so now we've gotten these data, and we can just look at these tables. So here you can see, so GMBC 0000, so this is the first bin, and then 1, 2, and all the way down to 278,000. So it's actually interesting. So these are ordered by descending quality. So the first ones, so here you can see 100% completeness, 0% contamination, 62 contigs, so not very fragmented, and at the bottom, 7,000% contamination. So at the bottom, these should really not be used for a lot of science. Okay, but let's do this in a little bit more more thoughtful, more rational manner by I'm gonna here start a script. I'm gonna call it getMags.py, and so this is just Python. I'm using this environment where I have two windows. So I'm gonna type on the bottom window, and then I'm gonna so the commands will be run on the top window. So we're gonna read this table. And index. Okay, and just check. Yep, here it is. And you can see that there's also this class. So there's this classification from GTDB-TK. There's some categorization that we've used, and there's some, the completeness, contamination, quality. So all of this information is there. Okay, so today, for the purposes of this tutorial, I'm going to say that, so what we want to get all the mags for Fusobacteria. I think we're supposed to call them Fusobacteriota nowadays. Fusobacteriota from dog gut metagenomes. Okay, so for that, I'm going to also need to load the metadata table for the samples. And okay, and this is a very technical thing, but this will show up. Okay, so for complex reasons, basically because of how things were done during the process, so samples often have two names. They have an internal name, and they have an external name, where the external name is the official name from ENA, the sample ID, but there's often an internal name. Actually, the bins as well. So if we just look here at the first one, you can see that so this is bin 000. So this is the identifier, the unique identifier, but has this other name where you can see here it has a sample ID. And so we're actually going to use that to add a sample column. And this is pretty good, but it's not. This is pretty good guess from GitHub, but it's actually genome. So this is going to take the first. So it's gonna this column genome gonna split by dot, and then just take the first one, and then we can let's just look to see what happened. Yeah, there it is, sample. So it got the right sample. All right, so now we have a column called sample, and we have a column called and we have the metadata table. So what we need to do is now merge these two. So basically do a join, and so here we can do merge, and we're going to merge the bins and the meta. And actually, so yeah, so I was thinking a little bit, but GitHub is actually correct. This is what we're going to do, except we are not going to be writing it to them. Okay, so after this merge, now we have this bins table where we've merged the two tables. So it's a table where, okay, so here's the sample ID. It's good to check that they're actually the same. And now we have this habitat. So these are the statistics for all the sample as a whole, which doesn't matter for us now. All we care about is actually this habitat. So we can use this to filter. So for example, say that we want the habitat, as we said, to be dog gut. No, not the. Okay. So we only now we only have dogs. And we can also filter for quality. And so for example, we can say completeness greater equal than 90. And let's say in contamination let's even be a bit stricter, less than 5. Okay, pretty good. Okay, so now we have all of these high quality bins from dogs, and just check there's 1,300 of them, and we could retrieve all of them, but let's actually do even a little bit better, where we want to get GTDB-TK. So there was a column called GTDB-TK. So this is the output of GTDB-TK. and we can look for, let's look for, no, what did I say? We're gonna oh, Fusobacteria. Fusobacteriota. I think this is how, yeah. Okay, yeah, so we're gonna look for those that are from the phylum Fusobacteriota, and so we can just check, there's 25 of them. And now let's just, okay. So all of these scripts and everything, so all of this, the link is below, there's a GitHub repository. So all of this is public, all of you can do at home. And now we have these bins that we care about. And so we can see there's 25, and here we have these identifiers. Okay, so now how do we actually get the FASTA files? Okay, so for that, we're gonna need to import. Okay, so first of all, I'm gonna create, this is dog fusos. I'm just gonna create this output directory. Okay, so that's the first thing. Second of all, and here I'm gonna copy and paste from the other. So this I just need to tell you, this you need to, so you can download them from this URL. So gmgc.embl.de, API, etc., and then you pass in there the bin ID that you want /FASTA, and that will give you the yes, that will give you the, basically that will give you, yes, they will give you the FASTA file. All right, and okay, and actually, all right, so this was not bad. This was GitHub Copilot just wrote this. So yes, so this here we used URL. We build the final URL for each bin. We get, and then we use request.get to do the HTTP request, and then write. And the only thing I'm going to change from is that so Copilot likes to name the FASTA files .fa. I like to name them .fna. So I'm gonna just to be very explicit that this is a nucleotide file, and just so we have a little bit of. Okay, now I'm gonna run this, and it might take a couple of minutes. It's getting one by one, but this will get all 25 files. So, and obviously you could have run this for all 1,000 files and or all 200,000 files if you want. But there it is. You can select. Here I chose the dog gut also because it's a relatively small data set. We have a lot more for the human gut. We can in fact we can quickly check. Let me just do this again. We can quickly check. Oops, sorry. Quickly check. So if I just get the bins.query quality equals high quality. No, I guess I spelled it wrong. High quality. Category, not quality. Category. So we have 46,000 in this category, high quality ones. And then if I look at the habitat and yep, value counts exactly, you can see that that we have 35,000 human gut, human oral 3,000, and if we actually a lot of the projects have also considered the medium quality mags. In this case, oops, did I do something wrong here? Yep, I guess I need. Oh no, I just had a. Yes. Okay. So if you consider medium quality as well, then we have 85,000 human gut mags and 14,000 oral mags, etc. So as you can see, this is a rich data set. Things are also annotated, so we didn't explore here, but you can go back to the original source. You have you can link this to the You can link this to genes, to the uni genes that we have. So everything is linked. It's a very nice data set. I'll mention though that, so this was done before we had SemiBin. So actually, the papers came out more or less at the same time, within 6 months of each other. But actually, the GMGC project started and was running before we had SemiBin. So all of this is done with MetaBat2, which is really excellent. It just happens that it's now it's gonna be in a few years, so we now do have better tools, but MetaBat2 is still pretty good. And so these are MetaBat2 mags. I can tell you that we are doing some SemiBin ones as well for some of these, at least for parts of this data set, and we'll probably, we have already made some of those available as part of the SemiBin manuscript, but we'll probably be making more available in the near future. All right, as usual, if you have any questions, any doubts, feel free to reach out, email, Twitter DM, YouTube comments, whatever, subscribe for more videos, and I will see you soon.